Hello everyone, Mr. Minnick's my name, math is my game. Today, this fine 6th day of February, I'm joined by my second period Algebra II class. They're really excited to be here. And I'd just like to start off by giving a shout out to the future Mr. Minnick. He's probably sitting in the back of the room taking copious notes as he always does. Before we get started in this theorems about roots of polynomial equations, are there any other shout outs? Travis Sinisfet gets a shout out from his sister. Any others? The Atlanta Falcons for blowing another lead. And everybody in that class. All right. So chapter 5, section 5, theorems about roots of polynomial equations. Some of these exercises go from pretty easy to what just happened. So let's look at the first one. The first one says, if P of X has any rational roots, the rational roots will be plus or minus the factors of a sub 0 divided by the factors of, I guess I should have written that in blue, the factors of a sub n. And you're probably thinking to yourself, what on earth is this a sub 0 and what on earth is a sub n? So to answer that, we got to go all the way back to when we first defined a polynomial. We said it was a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a whole bunch more plus a2 x squared plus a sub 1 x plus a sub 0. So the a sub 0 in question is just simply the constant term in our polynomial, And the a sub n that we speak of, is the leading coefficient in our polynomial. So if you think about factoring, the way we factored things is usually we look at the constant. And if we factor something that has a leading coefficient other than 1, then that number comes into play also. So this really shouldn't be any surprise. So the first example we're going to look at, example 1, it's going to go like this. List all the possible rational roots of P of X, which is 13x cubed minus 5x squared plus 8076x minus 4, let's say. Okay. So according to this theorem, according to this rule, if this polynomial has any rational roots, what we're going to have to do is look at the factors of a sub 0. So what is our a sub 0 in this particular instance? It's the 4. Plus or minus 4, you don't really need to worry about the sign. So this is the a sub 0. Now remember, the theorem says we got to look at all the factors of that. So what are all the factors of 4? 1, 2, and 4, right? Now we also have to look at our a sub n, and what's our a sub n in this example? 13, just the 13. So what are the factors of a sub n? 1 and 13, 1 and 13. So this theorem, it's pretty profound what it says. It says if there are any rational roots, what they'll be is plus or minus the factors of a sub 0 divided by the factors of a sub n. So when we go to answer this question, our answer is going to look like this. Plus or minus Well, we got to divide all these. We got to divide all these by those. So we're going to divide 1 by 1. What's 1 divided by 1? 1. Okay. So we're going to have plus or minus 1 on our list. Let's go to the next one. 2. We'll divide 2 by 1. What's that going to be? 2. We're also going to have to divide 4 by 1. So what's that? Plus or minus 4. Okay. So now we also have to go and divide all of these by this 13 also. So we'll have plus or minus what? 1/13. And then what? Plus or minus 2/13. And plus or minus 4/13. And that's it. That's it. Not bad, huh? So the question comes up, what's with all the stuff in the middle? What about these things in the middle here? Well, we really don't need to worry about those. If you think back to factoring, whenever we factored, we never really considered those until we started doing some other operations. So the middle stuff really has no bearing on what the possible rational roots are or could be. It kind of has a little bit to do with it, but the primary things that we look at are the constant and the leading coefficient. How do we feel so far, all right? Let's try one more example. Let's try one more example. Let's go to this Godding. Let's go to this Godding. So here we've got this polynomial 3x cubed plus 7x squared plus 6x minus 8 equals 0. So what's our a sub 0 in this one? 8. So here's our a sub 0 here. And then our a sub n would be what? 3. Well, 3 is prime. Its only factors are 1 and 3. 8 has a bunch of factors. 1, 2, 4, and 8. So our answer, our list of possible rational roots would be what? Plus or minus 1, 2, 4, 8, and then plus or minus. So remember, we're dividing a sub 0 by a sub n's factors. So plus or minus 1/3, right? Good. Right. There we go. So that's not so bad, is it? Well, what we could do if we want is we could go on and pick up the next theorems, or we could try to see how this is going to help us in the future. Question. Is there an easier way to write everything out like that? I'll be frank with you, not really. In the plus or minuses, you can't just use one blanket plus or minus. You do need to write plus or minus each time. Yeah. The good news is, obviously, if this is cubic, if the degree is 3, there's at most 3 answers. So the answers aren't going to be all of those. Okay. I guess what this kind of gives us is a starting point. Let's look at this next example, and hopefully this will clear things up. This problem 2 says, we're going to give you this polynomial, and we want you to find the roots of this. We want you to find the roots of this, and it's degree 3, so your answer is going to have 3 roots. Now, last week, they told you what one of the roots was. They told you what one of the roots was. Well, this time they're not going to. So you have to know, okay, if I have any rational roots, what are they? What are my possible rational roots? Plus or minus what? 1, plus or minus 2. Now 15's got a lot of factors, doesn't it? Yeah, so we could divide 15 by 3, so plus or minus 1/3 and 2/3. We could divide 15 by 5, so plus or minus a fifth, and 2/5. And then 15 could be divided by 15, so plus or minus 1/15 and 3/15. Oh man. So they want us to find the rational roots. Well, most of that list is a mess. I don't want to have to work with fractions if I don't have to. So where would be a good starting point? 1 or 2? I'm going to try 1. Is that all right? Everybody agreeable to that? So when I synthetically divide, I'm synthetically dividing by 1, so I'm going to go ahead and put the 1 in the box and see what happens. Remember last week I said you'll synthetically divide 1,000 times this week? Here's 1 of 1,000. There's 15, there's negative 32, there's 3, there's 2. Take your time when you do this synthetic division. If you mess up, it's going to create a nightmare on down the road. So we get 15, we get 15, we get negative 17, get negative 17, get negative 14. Now what should our remainder be if this ended up working? 0, good. 1 times negative 14 is negative 14. And this is not 0. I don't care what it is, but it's not 0. Dang it. We have to keep going until we find one. Yeah. Yeah. So we could try 2. Or maybe negative 1. It's a preference thing. It's a preference thing. I'm going to go ahead and try negative 1 before I move on to 2. Okay? So I'm going to go ahead and try negative 1 and see if that works. So we got 15, negative 32, 3, and 2. So there's 15. Negative 15. Oh, this is going to get big real quick. Negative 47. That's 47. That's 50. That's negative 50. That's not 0. So after two attempts in nothing, now we go around with squeaky doors the rest of our lives. We don't catch any fish. We don't ever unloosen or loosen any rusted bolts. Anybody know what I'm making a reference to? What invention gets our doors from being squeaky? WD-40. Everybody thinks they know what the 40 stands for in WD-40. They don't. It's not 40 ingredients. That's what everybody thinks. It took 40 tries to get it right. This could take 40 tries to get it right. Let's try 2. 15, negative 32. Thank you. And 2. I was looking at that last one, and that last one kind of reminded me of something. Everybody see what happened in that last one? Do you see in the last one how this was positive, and then this was negative, and then this was positive, and then had I actually subtracted that the next one would have been negative? Do you see how that happened? There's something really profound there. Something really special there. If I wrote an abbreviation on the board, let's see if anybody can tell me what that abbreviation LB stands for. I could give you a hint what the L stands for. I could say that it's the opposite of higher. Lower. It's a lower bound. What that means is if this function has any zeros, any roots, and all of them are rational, none of them are going to be any smaller than negative 1. So that means I don't have to try negative 2. If this thing has any rational roots at all, they're not going to be any smaller than negative 1. So I'm putting a lot of hope in this 2 here. I really hope this 2 works. It works? Did it? So we got the 15, we got the 30, we got the negative 2, and negative 4, and negative 1, and negative 2. Yes! Yes! Well, it didn't take us 40 tries, but felt like it, didn't it? Yeah. Yeah. So last week, exercise number 30 was one that kind of segues into what we're doing now. Okay? That's a cubic function, and what we did is we really divided this by x minus 2. Would everybody agree? We put a 2 in the box, and we really kind of divided this thing by x minus 2. Okay, so we divided it by x minus 2, and our quotient is made up of all these coefficients down here. Now, we took a cubic and we divided it by a linear, so that's 15 what? 15x or 15x squared? Or 15, it's 15x squared. So our quotient then is 15x squared, and then what? Minus 2x minus 1. So our end goal is to fill in all those three spots with these roots. Well, we found one of them. What's one of the roots? 2. One of the roots is 2. So what's that? We only got one out of that. But there is good news in all this. The good news comes from the fact that now what's left is a quadratic. And guess what we spent all of chapter 4 learning how to do? Quadratics. So we're going to have to use all of our chapter 4 recollection, knowledge, powers, skills to solve this. 15x squared minus 2x minus 1 equals 0. Could we factor that? I'll bet we could. It's got to be a 1 and a 1 here. No way around that. So maybe it's going to be a 15x and an x. Probably not, though. 3x and a 5x. All right. Now, this inner product gives us 5x. This outer product gives us 3x, and we want those to add up to negative 2. So we want the 5x to be negative, so we got to put a negative here, right? And a positive here. So that's how this thing factors. So by the zero product property, then 3x minus 1 is, I said 3x minus 1 is 0. So 3x is 1. So what's one of our other roots? 1/3. So 1/3 is one of our roots. Hey, that's in our list, isn't it? Imagine that. Huh. Okay. And 5x plus 1 equals 0. So 5x is negative 1. And so the other root is negative 1/5. X equals negative 1/5. Negative 1/5. So what we did is we took a cubic. We had no idea what any of the zeros were. Made a list of what could work. Tried it until we found one. Broke the cubic down to a quadratic, and then we just used chapter 4 stuff. That was a cubic. You know how big of a degrees we're going to be doing this with? 6. Quintics and is 6 called sextic? No, because if it were, then 7 would be septic, and that would stink. Yeah. Any questions, comments, concerns, short debates before we move on? I'm not a football person myself, but I did watch the Super Bowl up until about the third quarter. My sister believes that the NFL is rigged. I don't know. Do we want to try another one of these, or do we feel like we got the idea? Try another one? Got him? Well, we'll run through this one real quick. So here we go. Possible rational roots. Plus or minus 1, 2, 3, 6. Hey, if I divide 1 by 2, I am going to get a half. What if I divide 2 by 2? I'm going to get 1. Now, I already have 1 taken care of, so I really don't need to put that on the list again. So I don't need to be redundant. I don't need to say the same thing I already said over and over and over and over again. But I'm going to have this plus or minus a half. 3 halves I'm going to need. And I think that's it. Okay, so here we go. Let me try the 1, 2 question. Yeah, sorry, I don't know where my where all that showed up from. Sorry about that. Okay, so we got the 2, the 1, the -7, the -6. We're really good at synthetically dividing. Just got to make sure you take your time with this. And that didn't work. Oh man. -1. 2, 1, -7, -6. There's 2, there's -2, there's -1, there's 1, there's -6, and 6, and there it is. That didn't take long at all, did it? All right, so one of our answers is what? -1. Okay, so I got this quadratic left. 2x squared minus x minus 6 equals 0. Maybe it factors, maybe it doesn't. 2x and x. 2x, oh gosh. Let's try this again. 2 and 3, huh? Yeah. Minus, plus. So what are my other roots then? 2 and -3/2. And -3/2, right? You know why you're not allowed to use the TI Inspire to do these, right? It'll do it in like 1/10 of a second. Not even. Well, this next idea kind of reminds me of Mutt and Jeff. Question? Can you do the synthetic division with the calculator? That's a good question. The calculator, what you would do is you would evaluate the function, and if it evaluated to be 0, then it would be a root. Let me load the calculator and show you a couple things. While the calculator's loading, I'm trying to think of things that just go well together, like chocolate and peanut butter, like cocoa and marshmallows, like milk and Oreos, green beans and jelly? That's a new one to me. Peanut butter and jelly go together. Snow days and sled riding. Mashed potatoes and corn? I was thinking mashed potatoes and gravy. Well, there's some things that just always show up in pairs, aren't there? Okay. Well, maybe it's kind of like this. Maybe it's the IRT or the ICT. Not to be confused with the ICP. And then there's another one called the CCT. The title of this section was Theorems, so this is abbreviation for theorems. This is going to be irrational conjugate and complex conjugate. So this says if Smartboard's not cooperating with me. There we go. If P of x has a root of a plus rad b, comma, then it also has a root of a minus rad b. The irrational conjugate theorem. Irrational zeros show up in pairs, show up in conjugate pairs. The complex conjugate theorem is real similar. It says if P of x has a root of a plus bi, hey, that's a complex number. Then it also has a root of a minus bi. A plus bi and a minus bi are called each other's conjugates. So complex number roots show up in pairs. Irrational roots show up in pairs. Peanut butter and jelly shows up in pairs. Seeds show up in pairs. Socks show up in pairs. Did anybody get the seed one? You ever eat a pear? Oh man, that was really bad. So let's go back for a second to that last one. What was that last example we looked at, that x cubed one? 2x cubed, okay, cool. 2x cubed plus x squared minus 7x minus 6. There we go. So 2x cubed, was it plus x squared? I'd like to give a shout out to Mr. Englehart for the hookup. Oh man, it's a fresh batch of cold brew. I'm never going to be the same. I am never going to be the same. That was so worth it. So plus, what do we got? X squared minus 7x minus 6. Now I got to tell it that do we want to use P or F? It doesn't matter. I'll use F. So f of x equals this. Okay. So I would be finding, f of 1, f of negative 1. Okay. Does that make sense? Okay. I don't know if that answered your question. Okay. I could also find polyroots of 2x cubed plus x squared minus 7x minus 6 for the variable x. And there we go. Okay. So it'd be nice if we could use a calculator on those. Are there any questions about these two theorems? Well, let's put them in use then. Let's put them into action. Problem 3 says some quartic polynomial. Some quartic. What's that mean the degree is? That means the degree is 4. Has roots, has rational coefficients, and they're telling you that rad 2 is a root. So let's think about what this polynomial would look like. Because rad 2 is a root, a factor would be x minus rad 2. And because 1 plus I is another root, one of the other factors would be x minus 1 plus I. But they're saying that this thing's got to be degree 4. Oh man. Well, what's another one of the roots? Not 0. Let's back that thing up. If a plus rad b is a root, then so is a minus rad b. So since rad 2 is a root, then so is negative rad 2. Okay? So this right here tells us negative rad 2 is 2. So we'd have x minus yeah, because when it's minus a minus rad 2, it would change that to a plus, right? Okay, so that'd be plus rad 2. And then look at what else this says. If a plus bi is a root, then so is a minus bi. So they're telling us that 1 plus I is a root. So guess what else is? 1 minus I is, bless you. 1 minus I is. So this is x minus 1 minus I also. Now you guys know our fearless leader in the school, right? Shout out to the principal, Mr. Dobrin. He walked into my advanced Algebra II class 2 years ago when we were doing this. You know what can make these problems difficult is if they ask you to put these things in the standard form. We're not going to do that just yet. Okay, I will save you that that task. I'll spare you of that today. Okay, if you could just write this in factored form, that'd be good. Let's look at God at 3. A cubic polynomial has real coefficients, and 3 minus 2i is a root, and so is 5 halves. What's the other root got to be? 3 plus 2i, okay? Because of this, 3 plus 2i is another root. Well, what about the 5 halves? We didn't say anything about rational ones. It was just complex ones and irrational ones. No, it wouldn't be negative 2/5 or anything like that. If this had some kind of radical in it, then there would be another one, but that's rational. These two theorems are only talking about irrational numbers or complex numbers. Okay, does that make sense? A little bit? All right. Well, let's try one more. Oh man, so we do have to put one of these in standard form to answer this question. What third degree polynomial function has rational coefficients and roots of -4? So because -4 is a root, what's one of the factors? Well, x plus 4. So we have another root of 2i, so that means a factor is going to be what? X minus 2i, and because 2i is a root, what else is a root? Another factor would be x plus 2i, and negative 2i is our root, right? We all right with that? So it makes sense to FOIL a pair of these first, either this pair, or maybe the first one with the last one. Which one makes sense more to FOIL first? These two or these two? Those two? Okay, so let's go ahead and FOIL that. So we'll eat our icing last. X squared. Hey, what happens with the 2ix and the minus 2ix? They cancel. So that's going to be minus 4i squared, but what's I squared? Well, what's I squared? -1. So it's minus 4 times minus 1. So that's going to be plus 4. Oh, so that's going to be x cubed plus 4x squared plus 4x plus 16. And the answer to that one would be not D, C, as in Charles. That wasn't bad. Could you do one like number 4? On tonight's exercises, I don't expect you to put that in standard form, but I would like to see if we could put that in factored form. Can we try that? Let's try to put that in factored form. So they're telling us it's quartic, so we're going to have P of x is x something something something. X what? Two minus the 3i, so we're going to be subtracting that. Right. So because this is a root, 2 plus 3i is also a root, so we'd have x minus the group of 2 plus 3i. And then x minus 8 and x minus 2. What do we think? I got to be honest with you. Multiplying out this, it's quite a feat. It's quite the chore. Everybody care to see how that's done? Okay. If I were doing that, I would redistribute. I would move some things around. I would write x minus 2 as a group, and then plus 3i. And I know you're thinking, well, it's the same thing. Well, it is, but it isn't. And then I'd have the x minus 2 again as a little group, minus the 3i. And then I go ahead and FOIL that back half. That's x squared minus 10x plus 16. So when I go to FOIL all this, I'm going to have x minus 2, the quantity squared. Well, that's x squared minus 4x minus plus 4, rather. Then I'm going to get plus 3i times x minus 2 minus 3i times x minus 2, so all that goes away. And I'm going to have plus 3i times negative 3i, which is going to be minus 9i squared, but I squared is -1, so that's going to be plus 9. So that's actually going to be plus 13. So really it's not too bad, but I skipped about 28 steps in there, and then I still got to multiply all that. So like I said, for tonight, if you could just write it in factored form, I would be more than fine with that. Okay? Questions? Comments? Shout outs? We got nothing, no shout outs? Anybody have any funny jokes? Do I have any funny jokes? The one joke I told the one time was really long. It took about 10 minutes. Um, so I don't think I have any jokes. Except maybe the magical tractor one. Magical tractor turned into a field. That was bad. On that note, it's been real. It's been fun. Have a great day. See you all next time. Good.